All right, now we get to where we are applying the binomial theorem to expand the following. So notice that my exponent is 5. That's a lot of multiplications. So I'm going to take the pattern that is at the top of this page, and I'm going to apply it to this binomial. First thing I want to do, though, is identify A, B, and N. So N's the exponent, A is just the first part of the binomial, B is the second part. So to expand this, I'm going to start with the combination 5 over 0. And then my A is x. It's going to go to the n power. And n is 5. Let's write 5. And my B doesn't show up in this one. So plus 5, I'm going to be counting up from 0 in the bottom of my combinations. And I get x to the 5 minus 1. And now my B is going to show up to the first power. Now I'm just going to write all these out, and I'll simplify them in the next step. So I'm going down from 5 to 0. So 5, 2, x to the 5 minus 2, 4 squared, plus 5, 3, x to the 5 minus 3, 4 to the third, plus 5, 4, x to the 5 minus 4, 4 to the fourth, and I need some more room. Last one, and I know I'm in the last one when I have the same number in my combination, x to the 5 minus 5, and 4 to the fifth. So I'm going to start simplifying this from the top. Now remember, if I have any number in the numerator and in the top of my combination and a 0 as my r, it's just 1. So I get x to the fifth. 5 and 1, that is one of my specials that reduces to 5. So the combination of 5 and 1 gives me 5, and I get x to the fourth, and we're multiplying by 4. I'm going to come back and do that multiplication. 5 and 2, it turns out that 5 and 2, when I put that in the combination, and I'm going to show you that just to start with, I'm going to type my 5, press math, probability, 3, and now I'm going to put in the 2, and there's my 10. Okay, so I get 10, and I'm on my third term, x to the 5 minus 2, that's x to the third, 4 squared gives me 16. The combination of 5, 3 will also give me the number 10. X to the 5 minus 3, which is 2, and 4 to the third, which is 64, plus, now I'm looking at 5, 4, so 4 is just 1 less than 5, that will give me a 5, and x to the 5 minus 4 is just x to the 1 power, and 4 to the fourth gives me 256. And my last term, 5 and 5, that's just 1. The combination of any number over itself is 1. And x to the 5 minus 5, that's x to the 0, so my x's go away on my last term. And I'm just left with 4 to the fifth, which is 1,024. Okay, so I've got some multiplications to do here. X to the fifth plus 20x to the fourth, plus 160 x to the third, plus it looks like 640 x squared, plus 256 times 5 is 1,280 x, and the last number is still 1,024. And that is my expanded. And it seems like a lot of trouble, but this is much easier than doing the multiplications that would be required to expand out x plus 4 multiplications and combining. Okay, use the binomial theorem to expand the following. It's the same idea, only I wanted you to see this fraction work. In fact, I'm going to stop this video. This one's going to take a while.